Greetings, Earthlings. Well, at this point, I have given up on trying to run TU58 emulator. I do have this laptop which runs Windows XP, but it uses a USB to serial converter, right? This thing. Okay, that thing there. And I can only get it using that program, that like bidirectional echo program. I can only get it to talk in one direction to the PDP-11. So forget it. We're giving up on TU58. We're going straight to disk at this point. So I've taken out the serial card, put that away for now. In its place, I'm putting in a DHV11, which is an 8-port serial multiplexer. Okay, that's 8 serial ports, but you don't access them the same way that you do serial ports. But if I wanted to run, like a time sharing system, Ristus E or heaven forbid Unix 211 BSD, it would have drivers for that. Okay. So I'm going SCSI here. This is an Emulex UC07 SCSI controller, and that'll go in the next slot. On the left-hand side, right? The Q-bus side of this backplane. Oh, this card, by the way, can go either in a QCD or a Q-bus. Q-bus, it's got jumpers on it, so that if you put it into a Q-bus slot, you can maintain the bus continuity. But in this case, I don't have to worry about that. Okay. So, there's a SCSI 50-pin SCSI cable. Now, I do have... Ow! I do have a couple of old SCSI drives. This one is, I think, 300 and some odd megabytes. This is out of an HP system. You can see the... maybe see the HP logo right there. So that was an HP drive at one point. 320 megabytes or something like that, I don't know. And I have this one. This one's a Mac Store. 760 megabytes. This is out of an IBM system. It says right here, manufactured for IBM Corporation. But the thing is, I don't know if those work. And actually, this one in particular, these capacitors, it's got a couple of big capacitors, and they look kind of bad, like they need to be replaced. And the other thing is that in both cases, the terminating bus termination resistors. I don't know if you can see that because it's the bus termination resistors have been removed. Okay, so. We'll get to those at some later time and see if we can make them work. But for now, I'm going to use this, which I took out of my Windows 95 machine. It's been living in there. This is a, what is it called? ZuluSCSI RP2040, okay? And that takes an SD card, and it can have virtual SCSI disks on that SD card. Okay, so that just hooks up thusly. Just hooks up thusly. It gets its power from the controller Uses the bus termination power, and it has the bus termination resistors on it, and they're switchable. It's got some dip switches here to configure. So that's what we're going to use for this. I've put 3 disk images on that drive, or on that SD card. So the virtual disk 0 is, I think, an RT11 system. Disk 1 is Ristus E, and disk 2 is XXDP. And to do that, I mean, you just copy the files. You find the disk images out there on the web, of course. You know, someone else has gone to the trouble to make them, and just copy them on there. And the file name determines what disk drive it's going to be. So you name one CD0.disk, and that'll not CD0, HD0. There you go, HD0, HD1, HD2. So I'll get this turned back around, and we'll fire it up and go through the configuration. There's a little configuration we have to do with the controller there, and see if we can get it to boot off of this virtual hard drive. Okay, so here we go. We'll fire it up. Make a lot of noise. And now the first thing I have to do is go into, configure this SCSI card by running what they call FRD, which is built into the card. Okay, so we'll go into the debugger, and we'll go 177.72150. Put 1 in there. This goes 30003. We go slash. We go 42000. We go 177.72152. That's good. And we go 200G. And so that's going to run the program here. And what we have to do is, we're using option 14, and do an automatic setup. And hopefully that will find my drives. There they are. No, we're good. Whoops. No. Okay, do you want to change the parameters? No. This scares me. All data on drive can be lost. You want to load the NOVRAM? Yes. And there we go. And so now let's list known units. 0, 1, and 2, they're all there. They're all different sizes. That all looks good. Okay. So at this point, we'll reboot. And these are going to look like RA something or other, RA81s or something. So it's going to be DU012. So we'll say boot DU0. This should bring us into RT11. Which takes a while to start up, obviously. But it looks like it's doing something. It's trying. I don't know, do I have to do anything here? Hit enter. Oh no, there it is, okay. Okay. So we're there. Boy, it's been, I have used RT11 before. It's been, well, over 40 years. So I don't remember much about it. I remember I didn't much like it as a system. We were running it on an 1104. It's a much smaller machine than this. But anyway, let's do a dir and see if that works. Hey, look at that. It's got a bunch of files, 243 files. The executables should be here. Okay. And, oh, it's got Tico. So let me run Tico. That's a text editor. Was a great text editor in its day, I guess. Totally character-based, but maybe a little known fact. The original Emacs was written as Tico macros. Okay, I don't remember how to use Tico, so maybe I remember how to get out of it. Okay, good. So that's RT11. It looks like it runs. That's cool. Let's reboot. And let's try disk 1. Boot DU1. This is Ristus resource sharing time sharing system, something like that. RSTS. I don't remember what that stands for. The E is extended, as I recall. And again, this system probably does have a driver for that serial multiplexer card, although the system that I'm booting probably isn't configured to run with that. I will say I have never, to the best of my recollection, run Ristus before, used it in any way, shape, or form, so I'm not sure what we can do except see that it boots up. Today's date. Well, today's date is 5 May 23. I believe this version 10.1, is Y2K compliant. Current time, oh, I don't know. What time is it? Do we care? No. Let's say 1900. Start time shift. Let's say no. Option start. Well, okay, I got some stuff I can do here. I don't. Okay. It's hardware. Hardware sub option. List. Okay, TT0, that's the console port. RU0, that is our disk controller, and you see we've got 3 drives there. DM0. DM. Is that multiple? No, it's DH0. I'm not sure what that is. KW11L, I think, is the line time clock, 60 hertz. Okay, it has built-in floating point, 22-bit data space, separate instruction data space cache, J11B CPU. Yeah, cool. So DM0 might be that multiplexer. It might have actually recognized it, which is scary. Exit. Okay, option. Let's go into multi-user mode. At this point, I have no idea what I'm doing, except waiting like it tells me to. I don't know why it thinks it has to rebuild the disk. That's a scary thought. Okay. 46 devices disabled. That's nice. Well, maybe it knows about all possible devices. It could be smart and, figures out what devices are there and automatically loads the drivers for them. That would be cool. Okay, you gonna do anything? Nothing there. Proceed with system start, yes. Okay, there we go. It's starting up. So, again, this seems to work. Okay, not a valid device. Oh, okay. Starting spoolers. Printer. I don't have the printer card installed. I'll probably at some point go and put it in. Hey, Ristus E is on the air. Memory would be fragmented. I don't know what to... Oh, user. Uh-oh. Well, obviously it doesn't like a blank. Admin? I don't know. I don't know. Okay. So that was that. Okay. We'll reboot. Probably trashing the disk drive in the process. And let's boot DU2. And this is XXDP, which has a bunch of like diagnostics. And I don't really know how to use this either. But we'll see what happens. You could think of it as a minimal operating system. Hello? Hello? Are you going to start? It's these long delays kind of scare me. Okay, but it is, trying to do something. This could be the bootloader talking, and then that delay could be actually loading it into RAM. 124K words of memory. Well, that's a lie. It's got 512K, but this code probably only is written for an 18-bit system. Type H for help. Okay, H. Okay. Version. Oh, good. Oh, I see. We're in help. Okay. Thank you. Let's Control C. Okay. Version. Okay. Whatever. Can I do a dir? I said. Boy, and I thought I had a fast system, as PDP 11s go. I don't know if it's going to do anything. Oh, there it goes. Okay. Yeah, it just takes its own sweet time. Looks like the BIC files are the diagnostic binary, I guess. I don't even know what it is. I saw man, that's a lot of files. I saw something with an F, like FP, like floating point. Let's see how smart this dir is when it comes back. Thank you. Dir FP star. And wait, and wait, and wait, and wait. Invalid file name. Oh. What? It may not, have wildcarding built in. It might be that dumb. Oh no, and I say that and there it goes. Okay. FFP CB0. FFP. Okay, that's a FFP. Sounds like a floating point. Oh, these are binaries versus bit. Well, let's try this one. FFP-AA1. Let's say run FFP-AA1. Yes, that is correct. Okay, I don't know, switch registers. Just did enter. Okay. Well, there you go. It's running, 1134 FVP diagnostic. Okay. Whatever. I guess the floating point instructions are going to be the same. Presumably. So, anyway, it boots.